Remember, step 12 said I can graph lines and inequalities. So technically, we're only halfway through what we want to do in step 12. We've only learned how to graph the lines, not the inequalities. That might seem discouraging because the first part took over 20 minutes. But I'm happy to tell you that the last part is pretty simple. Once you can graph the line, making a graph of an inequality is not much more complicated. There's just two things you need to remember. We need to add shading, and we need to decide if the line is solid or dashed. If you recall from step 10, if it was greater than or equal to or less than or equal to, we used a closed dot. And if it was strictly greater than or strictly less than, we used an open dot when we were graphing on a number line. The same thing is going to be true. If it's greater than or equal to, less than or equal to, we're going to use a solid line. And if it's strictly greater than or strictly less than, we're going to use a dashed or open line. So that takes care of this piece. Greater than or equal to, less than or equal to, solid line. Greater than, less than, dashed line. And the shading is best determined by getting y by itself on the left. On the left side. From there, if the symbol is greater than or equal to or less than, or strictly greater than, we're going to shade above the line. And if it's less than or equal to or strictly less than, we will shade below the line. But again, this only holds true if you have y isolated on the left side. Otherwise, this trick will not work. Let's apply it. I've taken the equations that we had from our last three examples of our step 12 line notes, and I just changed them out. So they've already been graphed. But again, I said above, it's helpful with inequalities to have y isolated on the left side. So let's do that with this first inequality. I'm just going to rewrite it. X minus y greater than or equal to 3. I'm going to subtract x from both sides. Negative y greater than or equal to 3 minus x. Finally, I need to divide by negative 1. And if you recall from step 10, when we divide by a negative or multiply by a negative and we have an inequality, we flip the symbol. So now I have negative 3 positive x. Because if you recall, 3 divided by negative 1 is negative 3. Negative x divided by negative 1 is positive x. Going one step further, I could rewrite it y is greater than or equal to x minus 3. That way I can clearly see that my m is 1 and my b is negative 3. I begin at negative 3 and I go up 1, right 1, up 1, right 1, up 1, right 1. This is a solid line because it is greater than or equal to, ends up being less than or equal to. And now, once I have y isolated, this literally means shade below the line. Shade below the line. So I'm going to pick up my highlighter to shade. Which part of my graph is below the line? it would be this section right here. So I shade below the line. Now, another method is to use a test point. And as long as your line does not go through the origin, 0, 0 is a good test point to use. Let me show you how a test point would work. I'm going to use the point 0, 0, which means x is 0, y is 0. And I'm going to put them in to my inequality. Is this true? Is 0 less than or equal to 0 minus 3? Is 0 less than or equal to negative 3? No. Which means we do not shade this test point. We shade the other side of the line. Let's take a look at the next one. We're trying to get y by itself. 10x is greater than negative 5y. I need to divide by negative 5, which cancels out on the right, but it does cause my sign to flip. So now I have negative 2x is less than y. And again, I want my letter on the left, so I'm going to flip this entire inequality over so that I have y is greater than negative 2x. This is a dashed line, so I need to go back and make my line dashed. The best way to make a dashed line that looks nice and straight is to start with a solid line and then just go back through and erase a little bit until you have a nice dashed line all the way through your graph. And then finally, we're going to translate what this means. This says shade above the line. Well, here's my line. Which half do you think is above? That's right, it would be this half. This is another way to shade. You don't have to make it completely shaded in, but if you want to, you can. Just takes a little bit more time, a little bit more coloring. You can go right up to the line and shade it in. We're shading this half of our graph. All right, for our last one, we just need to get y by itself. 4x is less than 2y plus 6. I'm going to subtract 6 from both sides. 4x take away 6 is less than 2y. I'm going to divide by 2. 4 over 2 is just 2x. Negative 6 over 2 is just negative 3. So this says begin at negative 3 and go 2. Up 2, right 1, up 2, right 1, up 2, right 1, and we get the same line that's already here. This line needs to be dashed. So again, I'm going to pick up my eraser and make it a dashed line. Because it is strictly less than currently, that symbol. Remember, we want to get y on the left, So if I move y to the left and everything else to the right, I do need to flip my symbol over. This says shade above the line. Here's my line. Does this side look like it's above it? Or is this side above it? Another way to think about it, here's my y-intercept. Go above the y-intercept. Sometimes when lines are more steep than other lines, it's difficult to tell where above would be. So it will be on this side. Shade above the line. And that's really all there is to it to graph a linear inequality in two variables.